to be solving the 2012 AMC 10A problem 24. Let's read through the problem. It says, let a, b, and c be positive integers with a greater than or equal to b greater than or equal to c, such that a squared minus b squared minus c squared plus ab equals 2011, and a squared plus 3b squared plus 3c squared minus 3ab minus 2ac minus 2bc equals negative 1997. What is a? So let's just write down whatever we have. So the question's asking for what a is, and we know a is greater than or equal to b is greater than or equal to c, and then we also have these equations right here. Plus ab equals 2011. Then we also have a squared plus 3b squared plus 3c squared minus 3ab minus 2ac minus 2bc equals negative 1997. So at first we might think we have to do something with these equations, and we'd be correct if we thought of doing that. So there's two possible things that we could do here. We could either add the equations or we could subtract the equations. We see that adding the equations is going to make all the a squared, b squared, c squared terms have the same coefficient, and the ab, ac, bc terms are all going to have the same coefficient then. So let's add them, because it seems to give a cleaner result. So adding these two equations gives us 2a squared plus 2b squared plus 2c squared. Then positive ab plus negative 3ab is minus 2ab. And then we just have this minus 2ac minus 2bc equals negative, it wouldn't be negative. It would be 2011 plus negative 1997, which is 14. So from here, you might think we have to divide every term by 2 so that we can simplify the equation, but I'm actually going to do something different than that, and I'm going to combine these terms in a different way by breaking apart the 2a squared, 2b squared, and 2c squared. By that, I mean I'm going to break the 2a squared and 2b squared into a squared minus 2ab, which is right here, plus b squared. And then I'm going to take the other a squared, and I'm going to pair it up with negative 2ac and a c squared. So minus 2ac plus c squared. Now we've eliminated the 2a squared because we have a squared here and we have a squared here. And then finally I'm going to do b squared. So then we've eliminated the b squared. And then also we've already eliminated these two. Then minus 2bc. So we've eliminated that one. And then plus the other c squared. So then we've eliminated the 2c squared. And this is still equal to 14. Now from here what we can do is we can use these three. And we can write a minus b squared plus a minus c squared plus b minus c squared. And this is equal to 14. Now in the question it says a, b, and c are positive integers. And so this means that each of these squared terms also have to be integers. So the only set of three squared numbers that add up to 14 is 1, 4, and 9. And so now we have to find out which one is which. So right off the bat, it's clear that a minus c squared has to be 9 because those two have the biggest gap. One's the smallest, one's the largest. So we can say a minus c squared is equal to 9. And this means that a minus c is equal to 3 because a is greater than or equal to c. Now, it could be a minus b squared is equal to 1 or b minus c squared is equal to 1. So we need to try both cases. So right now I'm going to test out the case in which a minus b is equal to 1, because if a minus b squared is equal to 1, then a minus b is also equal to 1. And then this would mean that b minus c squared is equal to 4 and b minus c is equal to 2. Now from here what I'm going to do is, so that we don't have to deal with 3 variables in just one equation, or 3 variables, 2 equations, I'm going to find all 3 of these in terms of a. So we can rewrite a comma b comma c as a comma, and then b can be written as a minus 1 from this equation. And then a minus c is equal to 3, and so c can be written as a minus 3. And so now we have these three coordinates all in terms of a. So from here, what I'm going to do is I'm going to plug it into this top equation right here and see what I get for a, because that's what the question's asking for. It's saying, what is a? So plugging these in, we're going to get a squared minus b squared, but we wrote b squared as a minus 1. So a minus 1 squared minus c squared, which is the same as minus a minus 3 squared. And finally, plus ab. And this is equal to 2011. And so distributing each of these, we're just left with a squared here. And then we'll get minus the quantity of a squared minus 2a plus 1 minus the quantity of a squared minus 6a plus 9. And then just this plus ab right here. And this is equal to 2011. Distributing the negative 1 into this and the negative 1 into this, we'll get a squared minus a squared plus 2a minus 1, then minus a squared plus 6a minus 9 plus ab is equal to 2011. Now once again, just a reminder, I'm using this equation up here, and I'm plugging in the relative values of a, b, and c into the equation to determine what a is. So these a squared and negative a squared eliminate. So those two eliminate, and then we also have, I should have rewritten, I'm going to rewrite this equation, because I had a b in there, but I was supposed to write b as a minus 1. So I'm going to rewrite the equation. This is where I messed up. So rewriting it, we'll get a squared minus a squared plus 2a minus 1 minus a squared plus 6a minus 9. And instead of ab, it should be plus a times a minus 1. This is equal to 2011. So expanding everything here, I can just rewrite this as a squared minus 1 plus a squared minus 1. So now we can eliminate the a squared and negative a squared, and then we have a negative a squared and a positive a squared. So then we're left with a 2a and a 6a, and then it's going to be this minus 11. So we're going to have 8a, so those two we've used, and then minus 1, minus 9 is minus 10, minus 10 minus 1 is equal to minus 11. And so this is equal to 2011. And so adding 11 to both sides gives us 8a equals 2022. And in this case, a is not going to be an integer, so we have to try the other case. And the other case is going to be if a minus b is equal to 2 and b minus c is equal to 1. So in that, we would have, I'm going to rewrite it here. So in that, we would have a comma a minus 2 comma a minus 3. And so I'm going to, once again, use this equation right here. And I'm going to get a squared minus a minus 2 squared minus a minus 3 squared plus a times a minus 2 is equal to 2011. A squared minus the quantity of a squared minus 4a plus 4 minus a squared minus 6a plus 9 plus a squared minus 2a equals 2011. This gives us a squared minus a squared plus 4a minus 4 minus a squared plus 6a minus 9 plus a squared minus 2a equals 2011. So once again, these two cancel out and these two cancel out. So we're left with 4a plus 6a minus 2a, which is 8a, and then minus 13 is equal to 2011. Adding 13 to both sides gives us 8a equals 2024. And so a is equal to 200 and so 8 goes into 22 times and 4 is left over. And so 5 and then 253. So the answer is A is equal to 253. And that's E.